I'm Jerry Scherzinger, Product Manager at Bimba Manufacturing. Cylinder performance. Let's get started with how to choose the right cylinder for your application. Specifying the right cylinder is the first and most important way to maximize the performance and longevity of your components. Several factors can impact efficient cylinder performance, including 1. Size and the force of the cylinder relative to the load. 2. Proper mounting. And 3. Environmental factors and more. That's why it's so important to pick a supplier that can provide a standard or custom designed cylinder for any application, no matter how unique. Cylinders can be categorized by the type of action they perform as well as the kind of construction they offer. Selecting the appropriate linear action depends upon the task to be accomplished. Cylinders can provide a variety of motion types. Many single-acting cylinders incorporate a built-in spring which returns the piston to its original starting position. The power in a single-acting cylinder is provided on the extension or push stroke only. A reverse single-acting cylinder is similar to a single-acting, but has the port on the opposite end to provide power on the retraction or pull stroke only. A double-acting cylinder has dual pressure chambers to provide power on both the extension and retraction stroke, eliminating the need for a spring return. To determine what size cylinder the task requires, you need to answer 3 key questions: load, velocity, and air pressure. How heavy is the load to be moved? Set by machine design. In order to move the load, you need to choose a cylinder that provides force greater than the load. It's a good idea to allow an additional factor of 25% force overload to What's the minimum effective air pressure, and is your pressure source constant? To maximize cylinder life and performance, you need to provide consistent airflow at the minimum effective pressure to maintain the desired velocity. Ideally, the cylinder should be able to move the minimum load at the minimum acceptable velocity and the application is a little different and other factors may apply. It's always wise to make your cylinder size selection with the expert assistance of your cylinder manufacturer or distributor. Once the cylinder size has been determined, here are a few things to consider. Stroke length. Calculate how far the piston needs to extend or retract to perform the task. Spring force. The spring force of the cylinder must be sufficient to return the piston to its start position. Overall dimensions. You need to accurately measure the space available to be sure it will accommodate the cylinder's mounting and operating requirements. Choosing the correct mounting style for your cylinder's size, force, and function has a direct effect on its service life. The wrong mounting or incorrect installation can result in side load, which creates excessive wear on the piston rod, rod bearing, and seals. When wear occurs, leakage usually follows, and that's how cylinders fail. Side load occurs when a load is placed on the piston rod without guidance or support, or when the mounting and piston rod connection are misaligned. Pivot type mountings: clevis, pivot, and trunnion. These types of mountings can eliminate side loads in one plane, but careful alignment in the other plane is crucial. Rigid mount cylinders. To avoid side loads, side-mounted, nose-mounted, flange-mounted, and face-mounted cylinders must be carefully aligned with the direction of load travel. Special options are offered with many spool pistons. These options are used to help reduce side loads by spreading out the distance between the rod bearing and the piston, thus reducing the effective loads at these 2 points. Cleaning after each stroke to prevent foreign substances from entering the cylinder. Consistent cylinder speed with flow controls. Inconsistent air pressures can cause unpredictable stroke speed rates, and air pressure that's too low may cause irregular movement of the piston rod during the stroke. The solution to these problems is installation of a flow control device on your cylinder to assure constant controllable airflow for precise and consistent speed control. The working environment can have a direct negative effect on your cylinders. Here are some of the environmental factors to consider to prevent or counteract negative effects on your cylinders. Is the operating temperature outside of the normal range of -20 degrees Fahrenheit to +200 degrees Fahrenheit? For best results, specify cylinders and seals constructed of heat or cold-resistant materials, and be especially vigilant with regular maintenance. Will the cylinder be exposed to radiation, caustic washdowns, or other harmful substances? At the work site, cylinders are often exposed to harmful substances related to the specific process. If the substance is corrosive, special finishes and materials help prolong the cylinder's service life. When it threatens to contaminate cylinder interiors, mechanical solutions such as wipers and scrapers offer protection. For extra protection, you can install rod boots, which are bellows that fit around the rod piston and expand and contract as the rod extends and retracts. Extend the life of your cylinders with prescribed lubrication and maintenance. Recently, cylinders permanently lubricated from the factory have become much more popular, lessening the importance of maintaining proper lubrication levels through the cylinder's life. However, for cylinders that require lubrication, one of the keys to maximizing the life of pneumatic cylinders is maintaining the proper lubrication levels. Cylinders that are not sufficiently lubricated can overheat, causing damage to components and degradation of seals. These tips will help you achieve maximum cylinder performance in any application you choose. To learn more, please visit us at www.bimba.com. Thank you.